Imagine you update a single dynamic group rule in your console. You hit save, and instantly 500 critical production servers are network contained.
Yeah, your company's revenue just flatlines.
Right. The phones light up, and you're just staring at your screen, realizing you just completely nuked your own environment.
Because you assumed Falcon handles grouping like, I don't know, some forgiving standard sauce application.
Where mistakes can just be undone with a quick Ctrl-Z.
Exactly. And it doesn't.
It really doesn't. Look, you are listening to this deep dive to Master Domain 4, which is a group creation for the CCFA exam.
And we have a massive stack of official documentation and architecture guides to get through today.
Yeah, and let's get this straight. Right now, we aren't going to hold your hand.
No, absolutely not. If you don't master the absolute bedrock logic of Domain 4, your endpoints will be left exposed. Or worse, you become the insider threat that takes down the network.
Right, the accidental insider threat.
Yeah, we are treating you like an administrator who literally cannot afford to make stupid mistakes.
So pay attention. You're going to learn the absolute non-negotiables of how hosts are corralled.
The massive architectural traps that are just waiting for sloppy admins.
And the strict, unforgiving syntax you have to use to make it all work. So before we can even look at complex policy application, you have to understand the foundational divide in how the platform categorizes endpoints.
Because if you screw up this baseline, everything built on top of it collapses.
Yeah. Your policies apply to the wrong machines, your exclusions fail, and you're left wondering why your environment is burning.
So we have to start with the strict difference between static and dynamic groups. This is your baseline.
Right?
And you must understand the architectural difference here, not just the surface-level definitions.
Let's define them. Dynamic groups automatically add hosts that match a specific assignment rule.
Right, and this is the critical, unforgiving part. They relentlessly remove hosts the absolute second they no longer match that rule.
What do you absolute second?
Yes.
Yeah.
There is no grace period. There is no confirmation dialogue asking, are you sure?
No safety net.
None. And static groups, on the other hand, require explicit manual host assignment. You put them in, you take them out.
So let's get away from those outdated analogies, like a static group being a club VIP list and a dynamic group being a breast code.
I hate those analogies.
Right, they're too simple. Let's talk about the actual mechanism. Under the hood, a dynamic group isn't a folder you put things into at all.
No, it's not.
It's a saved search query that is continuously running in the background, evaluating telemetry from the sensors.
Yes, that is the precise technical reality. It's a continuous evaluation loop.
And if a machine's attributes stop matching that query for even a second, the machine simply vanishes from the view?
Gone. And knowing that tells you exactly why you use one over the other.
So why use static then, if dynamic is so automated?
You use static groups for assets that absolutely cannot be subject to the whims of an automated attribute change.
Like what? Give me an example.
Think about a cluster of highly critical domain controllers, or fragile legacy servers where a sudden shift in prevention policy would just break a core business function.
Right, the servers that keep the lights on.
Exactly.
Yeah.
You do not want those servers drifting in and out of policy groups because some automated tag got dropped or a subnet changed. You demand rigid manual control over those.
And everything else.
Everything else in your environment, your thousands of workstations, your standard cloud instances, all of that should be scaled through dynamic groups.
Which brings us to the friction point. We have these two completely different mechanisms, manual assignment versus continuous automated querying.
And that architectural friction leads directly into the biggest trap you will encounter on the exam.
Yeah, the platform handles these two group types with absolutely zero flexibility.
Zero. Pay very close attention to this. You cannot change a host group's type after it has been created, ever.
Okay, let me push back on that for a second.
Go ahead.
Because from a modern UI perspective, that sounds incredibly inefficient. It's modern cloud software. Why can't the API or the console just flip a Boolean flag in the backend database from static to dynamic?
Because you're thinking about it like a simple UI constraint, and it isn't. The architecture doesn't care about your administrative convenience.
Ouch, okay.
It's the truth. The database schemas required for these two types are entirely different.
How so?
Well, a static group relies on a standard relational database mapping. This host ID is linked to this group ID. It's a static lookup table.
Right, a simple one-to-one or one-to-many relationship.
Exactly. But a dynamic group, as you just pointed out, requires the platform's compute engines to continuously process attribute-based filtering against a streaming pipeline of telemetry.
Oh, so it's active compute versus passive storage.
Yes. It is a fundamentally different computational mechanism. You cannot just toggle a static table into a real-time event streaming processor.
So if I make a mistake, say during a massive deployment, I realize the group I set up as static actually needs to scale dynamically.
You have to burn it down.
Just delete it.
You mercilessly delete the existing group, and you create an entirely new one from scratch. Do not waste time looking for a workaround during the exam.
So if there's a multiple choice question about migrating a group type,
The only correct operational answer is destruction and recreation. It is a hard constraint built into the core logic of the platform.
okay, so we've established a hard wall between manual and dynamic. You can't cross the streams. But let's look at how large enterprises actually operate.
Right.
Nobody manually clicks to add 500 critical servers into a static group. That's insane. They write automation scripts, they use orchestration tools.
Of course they do.
But if static is strictly manual and dynamic is strictly platform automated, what happens when a sophisticated admin uses their own external APIs to automate their manual assignments?
That creates an architectural paradox,
Exactly.
which is exactly why CrowdStrike had to build a mutant third category. If you are orchestrating environments at scale, you are going to be using static by ID groups.
Static by ID.
Yes. And I will warn you right now, do not confuse this with standard static grouping.
Why not?
Because static by ID is exclusively designed for API and automation-driven host management workflows. The defining characteristic here isn't just the API usage. It's that hosts are identified and managed strictly by their device agent IDs, their aids, rather than their host names.
Okay, I have to stop you there. Why the absolute obsession with agent IDs?
What do you mean?
I mean, a 32-character hexadecimal string is impossible for a human to read. Why not just configure the API to target the host name? It seems like an unnecessary complication to force administrators to script against random hex strings instead of machine names they can actually parse in a log file.
That exact mindset is why untrained administrators cause network-wide failures.
Well, tell us how you really feel.
I will. It is the operational truth.
Yeah.
Host names are unreliable garbage.
Garbage.
Yes. Think about it. Host names change when a machine is repurposed. They get duplicated by lazy provisioning scripts. They get spoofed by attackers trying to blend in.
Okay, fair point.
Now remember that an API executes at machine speed. It requires absolute precision. If your automation script targets a host name and your DNS is lagging by even, 3 seconds, or a duplicate DHCP lease exists,
No, man.
yeah, your script might accidentally apply a strict network containment policy to a critical production database instead of a compromised laptop.
Yeah, that would be the definition of a resume-generating event. The script executes perfectly, but it hits the wrong target because the label was fluid.
Exactly. The agent ID, or AID, eliminates that risk completely. It is a 32-character hexadecimal string assigned locally at the exact time of sensor installation.
So it never changes.
Never. It is the absolute immutable cryptographic fingerprint of that specific sensor installation. It does not change as the user renames the computer. It does not change if the laptop moves to a completely new subnet halfway across the world.
So APIs require this level of precision.
Yes. If you are using APIs to group hosts, you must use static by ID, relying on the AID. If you try to use host names, you are doing it wrong.
So if you want to automate your manual entries securely, you use APIs, you target the immutable AID, and you dump them into a static by ID group. That solves the static side.
Right.
But what about instructing the platform to automate your dynamic groups? We established earlier that a dynamic group is basically a saved search query continuously running against telemetry.
Yes, that streaming pipeline.
So how do you actually write that query? You have to speak the platform's exact native language, and in this ecosystem, that language is FQL combined with center tags.
Falcon Query Language, or FQL, is mandatory for writing dynamic assignment rules.
And you can't just guess the syntax.
No, you cannot guess the syntax based on other platforms you've used. You have to memorize the exact formatting mechanics. It strictly follows a field::value structure.
Notice the precise structure there. It is the field name, followed immediately by a colon, and then the value enclosed in single quotes. Field value.
Single quotes are mandatory.
But here is the major mechanical difference you have to grasp. You do not type out the Boolean word AND to combine criteria.
No, you don't.
The plus symbol acts as the AND operator.
And you need to understand why the engine uses the plus symbol. It isn't just an arbitrary design choice by some developer.
Why is it?
In back-end computing, parsing heavy Boolean logic trees with terms like AND or OR requires a lot of computational overhead. By using the plus symbol, the FQL is essentially structured like a URL-encoded string concatenation.
Oh, that's clever.
Yeah, it allows the sensor and the cloud streaming engine to parse the assignment rule instantly at machine speed. That saves crucial CPU cycles when evaluating millions of telemetry events a second.
That makes perfect sense. It's built for absolute velocity. Let's look at a concrete example that you will absolutely encounter on the exam and in the wild.
Let's hear it.
You need to create a dynamic group containing all Windows production servers.
Okay.
The exact correct FQL assignment rule you have to deploy is platform name, Windows plus tags, production.
I want to highlight the rigidity of that string. Listen carefully. All lowercase for the fields, single quotes around the exact values, tightly connected by that plus sign.
No spaces.
No spaces. If you try to use commas, or if you write out the word AND, the query fails.
And what happens when it fails?
The engine will not parse it, your group will remain empty, and your hosts will sit unprotected. Let me say it again. Platform name, Windows plus tags, production.
Get that tattooed on your arm for the exam. But an FQL query, no matter how perfectly optimized, is entirely useless if the underlying data isn't there to be queried.
True.
The engine is looking for tags, production. Where does that tag actually come from? The platform doesn't just magically know a server is meant for production.
No, it doesn't. And this is where we talk about deployment hygiene, which is, frankly, where most administrators fail.
Yeah, they get lazy.
Sensor grouping tags, the actual data feeding your FQL queries, those are applied locally at the exact time of sensor installation using command line parameters.
Wait, let's look at the logistical nightmare that creates. Are you saying that if my deployment team pushes out the sensor but forgets to apply the grouping tags parameter during the command line installation phase, I am stuck doing manual cleanup later?
Yes.
Why can't I just bulk add the tags in the Falcon console once the hosts check in?
Because if you do that, you have already lost.
That is harsh.
I have zero sympathy for poor deployment hygiene. Think about the timeline. By applying the tag at the command line during installation, the absolute moment that host checks into the Falcon cloud for the very first time, it immediately transmits that tag.
Right.
The continuous evaluation engine instantly matches your FQL rule, and the host is dynamically dropped into the correct group with the correct strict prevention policies applied on day 0. Minute 0.
Ah, I see. So if I fail to tag it at install, the host checks in completely naked.
Naked and vulnerable.
It falls into a generic default state with baseline policies until I manually notice the error, log into the console, and apply the tag after the fact.
Exactly. And in a highly contested enterprise environment, that window of vulnerability between a naked check-in and your manual console cleanup, that is all an adversary needs.
Just a few minutes.
That's it. Deployment hygiene is security. You do not fix this in the console later, you get it right at the command line, period.
Okay, so tag at the command line to ensure day 0 classification. Group dynamically with FQL using the plus sign for computational speed. Or use static by ID with aids for API orchestration. That is the architecture of group creation.
That is.
But let's bring this all together into the inevitable collision point. Because your deployment hygiene was flawless, your queries are perfect, but what happens when a single endpoint ends up belonging to multiple host groups simultaneously?
And it absolutely will happen. Enterprise architecture is messy. A single host can, and routinely does, belong to multiple host groups at the exact same time.
Give me a scenario.
Sure. A host might be caught by your FQL dynamic group for all Windows machines, right?
Yeah.
While simultaneously being placed via API into a static by ID group for executive laptops.
Okay, but those two groups are going to have entirely different security postures. The executive group might have a policy that disables USB device control because the CEO insists on using a personal thumb drive.
They always do.
While the baseline Windows group has a policy that strictly blocks all external media, so you have a direct clash of policies on a single kernel.
Yes. And when a host sits in multiple groups with conflicting prevention policies, the platform does not guess what your intent was.
It doesn't try to merge them.
It absolutely does not merge the policies together into some Frankenstein rule set. It uses strict policy precedence to determine which single rule set wins. You must deeply understand the computing logic of precedence.
The golden rule is actually simple. The policy with the highest precedence is the one that is applied to the host. Period.
But here is the counterintuitive mechanical fact where administrators completely choke when designing their architecture. Highest precedence is always the lowest numerical rank.
This trips people up constantly. They think 100 is a higher rank than 1. Why does the platform use lowest number wins?
Because you have to think like the code evaluating the rules. not like a human looking at a smart scoreboard. The engine processes policy precedence top-down, exactly like an array. It evaluates array index 0, which is rank number 1. Does the host match the group tied to rank 1?
And if the answer is yes.
If the answer is yes, it applies that policy, and the compute cycle terminates immediately.
It just stops checking.
It stops entirely.
Yeah.
It literally never sees rank 2 or rank 10 or rank 50.
Wow.
This design saves massive amounts of CPU overhead across the cloud platform. The first match, based on the lowest number at the top of the list, wins entirely.
So if your executive laptops group is assigned to a policy ranked number 1 and your all Windows group is ranked number 5, the CEO's laptop gets evaluated at number 1, it matches, and the engine stops.
Done.
The CEO gets their thumb drive access. The strict media restrictions sitting down in policy number 5 are completely ignored for that specific host because the engine never even reached them.
Precisely. And it is crucial to remember that the default prevention policy sits at the absolute bottom of this numerical precedence list.
You can't get rid of it.
No, it cannot be deleted and it cannot be disabled. It is the ultimate architectural catch-all. If a host manages to somehow not match any of your custom dynamic or static groups, it cascades all the way to the bottom of the evaluation list and receives the default policy.
All right, time for a blunt recap of the operational realities for Domain 4. Dynamic groups are running queries that automatically add and relentlessly remove hosts. Static requires rigid manual entry.
And the architectural trap. You cannot change a group schema after creation. You must mercilessly delete and rebuild.
Automation demands static by ID, which requires the immutable 32-character hexadecimal aid, never fluid host names.
Never. FQL syntax leverages the plus sign as the AND operator to parse strings at velocity, formatting as field value.
Sensor grouping tags must be injected at the command line during installation to eliminate day 0 vulnerability windows. And finally, when policies clash, the engine terminates at the first match. 1 always beats 10. The lowest number dictates the highest precedence.
Internalize the underlying mechanics of these facts. If you just try to memorize them without understanding the why, your environment will eventually break.
So true. Well, once this group creation slide deck finishes compiling in your Studio tab, do you want me to proceed with queuing up the slide deck for Domain 5 policy application next so we can keep this study plan moving?
Before you do, I want you to sit with a chilling scenario regarding everything we just covered about the mechanics of tags and precedence.
Okay.
We just established that a host drops down into the generic default prevention policy if it ceases to match any of your custom dynamic groups.
Right.
And we established that dynamic groups rely entirely on local sensor grouping tags.
Yeah, applied at the command line.
So what if a sophisticated attacker manages to gain local administrative access to a server and locally strips those sensor grouping tags right out of the registry?
Oh, man.
If those exact tags are the only thing dictating your dynamic group membership, an attacker could intentionally force their compromised host to fall out of your strict production group.
And the engine just evaluates it in real time.
The engine immediately evaluates the host, sees the tag is gone, strips away the production policy, and plunges the host back down into a weaker default policy at the bottom of the precedence list.
Wow.
By merely editing a local text string, they could effectively blind your custom defenses. Think very carefully about how your brilliant dynamic automation can be weaponized against you if your baseline configurations aren't secured.